We've all done it. Sat mesmerized by a campfire, watching the orange tongues of light lick the air, or stared into the tiny, flickering flame of a candle. It feels like something you should be able to reach out and grab. It has a shape, it moves, and it definitely has an effect on the world around it. But have you ever tried to define what it actually is? Is it a solid? Clearly not. A liquid? No. So, is it just a gas? Or perhaps that mysterious fourth state of matter we call plasma? For something that has been at the center of human civilization for 1,000,000 years, it is shockingly misunderstood. We are going to peel back the glow and find out, what is fire actually made of? First, we need to bust a major myth. Fire isn't a thing in the way a rock or a cup of water is a thing. You can't scoop fire into a jar and save it for later. That's because fire isn't a substance, it's a process. Think of it like a rainbow. A rainbow isn't a physical object hanging in the sky. It's the visible result of light bending through water droplets. In the same way, a flame is the visible evidence of a violent chemical reaction called combustion. It's a transition, a moment where matter is turning into energy and different types of gas right before your eyes. For this process to happen, you need the fire triangle: fuel, heat, and oxygen. You need something to burn, like wood, enough heat to kickstart the molecules, and oxygen to keep the reaction feeding itself. If you pull just one of those legs away, the whole object vanishes instantly. It doesn't just break, it ceases to exist. So, if fire is just a reaction, what is that glowing stuff we actually see? When you burn a piece of wood, the heat causes the wood to break down and release a cocktail of gases. These gases rise and react with the oxygen in the air. The flame itself is mostly made of these hot gases, but they are highly excited. As the atoms get superheated, they begin to shed energy in the form of visible light. The yellow color you see in a campfire actually comes from tiny unburnt specks of carbon, essentially microscopic pieces of soot. These particles get so hot that they glow, just like the heating element in a toaster. This is called incandescence. If a fire is burning perfectly clean, like on a gas stove, there's no soot to glow yellow, so you see the true color of the reacting gas molecules, a ghostly, transparent blue. You might have heard that fire is plasma, the same stuff found in stars and lightning bolts. This is a bit of a yes and no answer. Plasma happens when a gas gets so hot that its atoms lose their electrons and become electrically charged. For your average candle or campfire, the temperature actually isn't high enough to create true plasma. It's mostly just very hot gas and glowing dust. However, if you look at a high-heat welding torch or a bolt of lightning, the fire does become ionized. So, while fire can be plasma, the fire in your fireplace usually isn't. The color of a flame is like a secret code telling you exactly what is inside the reaction. Different elements release different signatures of light when they get hot. Copper creates a vivid green flame. Strontium burns a deep red. Potassium gives you a royal purple. This is exactly how fireworks work. Engineers aren't just making explosions. They are using fire to paint the sky using the light signatures of different metals. The color also tells you about the temperature. Blue is usually the hottest and cleanest, while orange is cooler and dirtier, filled with that glowing soot. Have you ever wondered why fire flickers instead of staying still like a light bulb? Fire is incredibly sensitive to the world around it. As the hot gases rise, they create a vacuum that pulls cooler air in from the bottom. This creates tiny tornadoes of air and turbulence. The flame is constantly shifting, bending, and pulsing as it tries to find more oxygen to breathe. It is essentially a living reaction, responding to every tiny draft in the room. It's easy to see why our ancestors thought fire was a living spirit or a gift from the gods. It grows, it breathes, it consumes, and it dies. But even though we know it's just chemistry, that doesn't make it any less extraordinary. Fire is a dance of molecules, a release of energy as old as the stars themselves. It's the bridge between the solid world and the world of energy. The next time you sit by a fire, remember that you aren't just looking at a thing, you are witnessing a violent, beautiful transformation of the universe itself. Thank you for watching What Exactly Is. If you enjoyed this journey through the molecules, please like and subscribe to join our community. We will see you in the next one.